In this video, we will use the vertex form of a quadratic to describe the transformations from the parent function. Okay, so let's talk about transformations for a second. The parent function, or the most simplistic quadratic equation, is y equals x squared. That y equals x squared is known as the parent function. So we have that parent function graphed here. Notice this is in vertex form, but our h value is 0 and our k value is 0. And so our vertex is 0, 0. Our a value is 1 and it's positive, so our parabola opens up. This is the simplest parabola we can make. So that's why we call it the parent function. All other parabolas are a transformation of this parabola, using those values a, h, and k. So a transformation is going to change either the size or the position of this parabola. So what we're going to explore first is how do those values a, h, and k affect the graph of a quadratic. We're going to take a look at the graph to be able to investigate that. Alright, so I have the parent function graphed here, y equals x squared. I know that because my vertex is 0, 0, and my a value is a positive 1, and so that's the parent function. Now what I'm going to look at is how a, h, and k affect the movement of this parabola. Let's first take a look at how h affects the parabola. So what I'm going to do is I'm going to press play here, and it's actually going to move my parabola. So notice what's happening. I'm only changing the h value. Notice also that the x value of the vertex is the only thing that's changing. So h is moving the parabola left and right only. Notice it's not moving up or down. It's only shifting either left or right. Notice when my h value is negative that this parabola has moved to the left from where it originally was. My original vertex was at the origin at 0, 0. But when my h value is negative, it shifted to the left. If I were to change this to a positive, notice how my parabola would have been to the right of my original vertex 0, 0. Alright, let's reset this to 0 and take a look at how k affects the parabola. So now I'm only changing the k value. Notice what's happening to the vertex. The vertex value is only changing for that y value. Notice that x is still 0. So changing k only moves that parabola up or down. Notice when my k value is positive that my parabola was up from where it was originally. Originally my parabola was at 0, 0, and my value is up here. If I were to change this to the negative, then now my value is lower or down from where it originally was for the parent function. Let's take a look at some examples using our h and k to transform the parent function. So from y equals x plus 2 squared, we can identify our h and k. Remember, x minus h is what we need to see, so this is really x minus a negative 2. Our k value is 0, which gives us a vertex of negative 2, 0. That h value, remember, will tell us how far we're going to move left or right. Our k value is going to tell us how far we move up or down. That means that we can use those values to transform this function. If I have an h value that's negative, where should my parabola move? My parabola should move left 2. We can see that in our points as well. My vertex is negative 2, 0, and this point that was at negative 1, 1 moved left 2. This point that was at negative 2, 4 moved left 2 to negative 4, positive 4. So the transformations that happened here were left 2. Let's take a look at that next example. Identify your h and k values to find your vertex. So our h value is 0 because we have x minus h here, plus k, so our k value is 5. So our vertex is 0, 5. We could find some points here, but notice how they're going to shift. If we have an h value of 0, that means we're not moving left or right. But if we have a k value of positive 5, that means our k value is going to shift our parabola up. So all of these original points should just shift 5 units up. So the origin where our original vertex was should just shift 5 units up. This point here should shift 5 units up. 1, 2, 3, 4, 5. And so on and so forth. So what are our transformations that happened here? Really, we just had a shift of up 5, and that's it. Let's take a look at number 9. Y equals x plus 1 squared minus 6. Identify those h and k values. H would be negative 1 because x minus a negative 1 would be here. K is a negative 6 because it's usually plus k. So our vertex is negative 1, negative 6. How would this shift our parent function? H moves our parabola left or right. So an h value of negative 1 means we're going to shift to the left. Our negative 6 here for k, well, k moves up or down. So a k value of negative 6 means my parabola should be over 1 to the left and down 6. And I see that's where my parabola ended up. We can see those values in the table that moved from the original. 0, 0 was our vertex. Our vertex moved to the left 1 and down 6. This point moved left 1 and down 6. This point moved left 1 and down 6. We're just shifting the parabola according to our h and k values. So our vertex tells us that we shifted to the left 1 and down 6. All right, let's take a look at what happens in this example. We're going to identify our vertex first, which should be positive 4, positive 1, x minus h plus k. Now, we have our vertex at 4, 1, so we should shift to the right and up 1. Also notice, though, that our a value here is negative. If you think back to one of our first lessons on quadratics, we looked at that a value as affecting whether our parabola opened up or down. Because this value is negative, our parabola is going to open downward. So we have another transformation that happens here. What would have happened originally is I would have taken that parabola that we started with for our parent function, and you flip it. You reflect it across the x-axis. So we have that reflection happening because of that a value being negative. Then I shift over 4 to the right because my h value is 4, and up 1 because my k value is positive 1. So describing those transformations that happen to the parent function here, we have a reflection across the x-axis because that a value was negative. We shifted to the right 4 because my h value was 4, and we shifted up 1 because our k value was 1. All right, in our next example, we have 3x squared minus 7. We identify our h and k values to be 0 and negative 7. That means I won't move left or right at all, but I would move down 7. So from my original, I would take that vertex and I would shift it down 7. But I want you guys to take a look at the shape here. Notice how that shape actually changed. In all of the previous examples, our shape of our parabola, how wide and narrow it was, had not changed. This is where we're going to talk about that A value. So let's go back to our investigation. Alright, so I have my parent function graphed here. We talked about how h and k can shift the parabola. But how does A affect the parabola? So first I'm going to have from 0 to 10, and we're going to see what happens. Notice what happens as A increases. Notice that it's getting skinnier and skinnier. But what happens as A decreases? So notice it's starting to get wider and wider. So what about when my parabola's A value is larger than 1? Because we start out with 1. That's our original parent function. If it gets greater than 1, so let me change this to 4. Notice how that is now skinnier than my original parent function. So what if I changed this from between 0 and 1? Well, what does that mean? That means that my A value would have to be a fraction less than 1. So for example, 1/2, or 1/3, or 2/3, or 4/5, any of those values. So I'm starting at my parent function, and what I'm going to do is try to see what happens when A is smaller than 1 but greater than 0. So notice what's happening. It's actually getting wider than my parent function. So when my A value is between 0 and 1, my function is wider than my parent function. When A is greater than 1, it's skinnier than my parent function. So notice that my A value here was 3, which is greater than 1. That's why this parabola is skinnier than it was originally. So I am still moving down 7, but my parabola is skinnier than the original. So what are the transformations that happened? Well, when it gets skinnier, we have a technical name for that. It's called a vertical stretch. It's like I'm taking that ends of that parabola like a rubber band and I'm stretching it vertically. And then we shifted down 7. All right, let's take a look at this problem. We have negative 1/2 for A, we have 3 for H, and negative 2 for K. So we know our H and K values tell us how we're going to shift left or right, or up or down. So the 3 for H, we know we're going to shift to the right 3. We know for our K value of negative 2, that's going to shift down 2. Is this parabola going to open up or down? Because our A value is negative, we know this parabola is going to open down. So we know that reflection is going to happen. We also know that our A value is 1/2 here, which means we're going to have that widening happen. So the parabola is going to be wider than it was originally. So we have this parabola here. Notice how we do that reflection, but notice how much wider it is than the original function. And then we're shifting to the right 3 and down 2. All right, so we had our points here, our vertex. We had 1, -4, 5, -4, and then 2 goes to -2.5, and 4 goes to -2.5. The transformations that happened here were what we call a vertical compression. That's the widening. So it's like we're taking our rubber band and we're squishing it vertically. We're reflecting across that x-axis, and then our vertical and horizontal shift. So let's summarize what we've talked about for transformations. We know that h is going to be the horizontal shift. It's going to move the function left or right. A positive value shifts right. A negative value for h shifts it left. K is the vertical shift. A positive will shift it up. A negative will shift it down. If a is negative, the function is reflected across the x-axis. In other words, the parabola opens down. If our a value has a value that's greater than 1, it represents a vertical stretch, like taking the ends of that rubber band and stretching it, which means it'll be narrower than the parent function. If our a value is between 0 and 1, so less than 1 but greater than 0, it represents a compression. Compressing means to squish it down, so it's going to be wider than the parent function. So let's take a look at some descriptions of some transformations and see if we can write the equation. So I have some values here, a, h, and k. What we're going to do is we're going to read through the transformations, then we're going to identify whether that affects a, h, or k, and what that would look like in our equation. So if we translated 2 units to the right, well, which of those variables affects a right movement? That would be our h value. If that's our only transformation, that means all I need to do is replace the h. The a and k values are not going to change from what they are in the parent function. And remember, in the parent function, y equals x squared, k is 0, and a is 1. So those values don't change, but I need to have my h be a positive 2. I know it's positive because we moved to the right. So I have y equals x minus my positive 2 squared. For 14, I have a translation of 5 units up. I know that k affects my upward movement. So my value for k needs to be a positive 5 because I moved up. A will still be 1 from the parent function, and h will still be 0 from the parent function. So I have y equals x squared plus 5. It is worth noting here that you actually don't need the parentheses when you write this equation. Translated 3 units left and 4 units down. I know my left and right movements are h. Because it was moving to the left, I know this 3 would be a negative 3. 4 units down is going to be my k value, and I know k is going to be a negative 4 because I'm moving down. So I'm going to have x minus a negative 3, which is why that becomes plus 3, squared minus 4. So I'm taking those h and k values and plugging them into my function. Translating 7 units to the right and 4 units up. I know to the right is going to be my h value, and up is going to affect my k value. So I know up means this is a positive 4, to the right means this is a positive 7. So I have x minus h, so x minus a positive 7 squared plus 4. Alright, in these next few examples, I have a reflection over the x-axis, then translated 3 units down. So a reflection over the x-axis is going to affect a. How is it going to affect a? Well, it's going to make sure it's negative. If we have that reflection, that means our a value is negative. 3 units down, I'm going to use my k value for that. So a is now going to be negative 1, and k is going to be a negative 3. h remains 0 from the parent function. Here I have a reflection over the x-axis. I know that's going to affect a. Translating 5 units to the right affects h, and 2 units down affects k. A is going to be a negative 1. 5 units to the right is a positive 5. 2 units down is a negative 2. So negative x minus h squared plus a negative 2 means minus 2 here. Vertically compressed by a factor of 1/3 and then translated 8 units up. A compression comes from that a value. So I know this compression by a factor of 1/3 is going to affect a. Translating 8 units up is going to affect k. So my a value is going to be 1/3, and my k value is a positive 8. Here in this last example, I have a vertical stretch by a factor of 2. I know that's going to affect a. A reflection over the x-axis is also going to affect a. And I have a translation of 4 units left. That's going to affect h. So I know my a value is going to be a negative 2. The negative comes from the reflection, and the 2 comes from the stretch. My h value is going to be a negative 4 because left is a negative movement. So I have negative 2 from the changes in a. 4 units to the left is x minus a negative 4, which makes it a positive in the equation.